Welcome everyone to Superintendent's Corner. I'm Dr. David Clendening, and today we are excited to talk about a new class that's being offered here at Franklin Community High School. One of our guiding principles really speaks to individual student growth. We're really striving to maximize potential for students. And over the course of the last few years, we've been talking about engineering and the need to continue to promote that. So we brought in our engineering expert, Mr. Rose, who is a first-year teacher with us in a Intro to Engineering class. So welcome to the studio today.
Well, thank you.
Well, just introduce yourself to the community and to the students who may not know you.
Okay, well, my name is Mr. Rose. I also go by Eric for when we're talking face-to-face. But the background-wise, I have a bachelor's degree in mechanical engineering from Rose-Hulman. I also have a master's in management, and I spent about 20 years in the manufacturing world in management and just changing companies, making them better. And after about 20 years of that, decided I needed to go into something where I didn't travel nearly so much. And now I am a professor for Indiana Wesleyan University and also teaching this engineering class here.
Well, that is great. And the engineering class is definitely new to us. Presently, you have a range of 10th, 11th, and 12th graders, I believe, in your class.
We have some freshmen in there.
And you have some freshmen, so
we have some
freshmen as well. So talk about your class. What do you guys, what's the purpose, goals, and objective of the class?
Okay, the class is intended to make engineering accessible to the students. And part of that is showing them that engineering isn't all about mathematics. There's a lot of math entrenched in it. There's a lot of science entrenched in it. But there's also a lot of thought process. And so what we're focusing on right now is teaching them the basic tools and how to think through problem solving so that they can create answers to whatever the question is. The intent of the class, by the end of the year, they should be able to go into a freshman level college engineering class and be able to work on projects in there and be totally comfortable.
That's outstanding. Well, I know that you started off having the people deconstruct items from curling irons to CD players and whatever else you could find at Goodwill, I think.
Yep, exactly.
But what else are you doing in the class as far as some project-based learning?
Okay, well, we also have had some very early projects. We're looking at how you can design in a team a way to move a ping pong ball the furthest with the power of one rubber band. That's the only constraint. One rubber band, and however you do it, we're going to compete face-to-face, head-to-head, and see who can come up with the most effective answer. We've also had projects where we have gone into AutoCAD and done actual design to prepare people for that documentation process that has to occur, because when you're coming up with the answers to an engineering problem, you also have to document all of your steps as you get there, because some of those steps may not turn out right at this point, but then further down the road you may decide you need to backtrack and pick up something that you dropped in the past because it is a better answer in the end than where you are. And so we've done that. We've had very hands-on projects, and we've also looked heavily at the idea of human considerations in design. How do we design so that our ideas and our projects and our products meet the constraints of the fact that people use these things?
Well, that's what an exciting time. I think you brought a couple project examples to show the audience, so let's why don't you bring them up and kind of walk us through what the kids had to do to meet the specifications for this activity.
Okay, well, we are actually right now in the middle of a 4-phase project. It is our hovercraft project. Phase 1, this was actually the Phase 1 hovercraft. It was based on a design. You can pick this design up out of the internet. And the intent was for each individual to just get a feel for the basics of how to create lift and then what a cushion of air can do for you once you've lost that friction. Each individual built their own, and part of that was learning the basics of the wiring, how to solder, doing the hands-on side of that, and then ultimately create a little hovercraft that just slowly moves along, but it shows you those basics of how you can create propulsion and lift with a single motor. That was Phase 1. Phase 2, we then broke into teams and allowed people to go with a much more open concept. The constraint for phase 2 was you have 2 motors, you'll have 2 props, and they were given a sheet of styrofoam and then told to come up with a way to make a hovercraft that'll go 50 feet in a straight line. You can then change its setup so that it will go in a 10-foot circle, and then we'd also check how much weight you could lift. And so it's totally open on this end of the design. Now this is, we're in the middle of that phase 2 right now. This is one of the team's projects. The design is, I'm going to say 80% student driven, if not more. Some of the things that happened from that original project where we tore everything apart in that first week, one of the students realized that a bracket from a hairdryer absolutely perfectly fit the motors that we had. It was as if it was made for that motor. And so what we did is, as an aside in the middle of this project, we created a silicone mold, and then we made about a dozen of these brackets out of plastic in the classroom. So we got a little side benefit of getting to see how to mold and cast plastics. But then they put these together. This design has the propulsion on the back, but then also has a lift underneath. And what they've had to do is come up with ways to balance it and make the hovercraft actually travel as well as lift. And in this one, it's a little bit louder. Turn on the back propulsion first. Be ready to catch in case it takes off.
All right.
So this is phase 2 of the 4 phases. The next phase, when we come back in the next semester, is to actually make a single hovercraft for the entire group that a person can ride. Phase 4 will break back into 2 groups, and we'll have a competition between the 2 groups to actually be able to have competing hovercraft that will go head to head.
Outstanding. Well, what a great way to engage students in that concept of exploration, understanding that math and science go together, but it's not just about the paper pencil aspects of math or the theories behind science. Well, you've done a great job of capturing that. If a student wants to get involved in engineering, what are some steps that they should consider?
Well, to get involved in engineering in general, the first step is to probably be comfortable with your math. The math and the sciences, you need to be comfortable with them if you go into an engineering program. Part of that is just doing it, being able to just feel comfortable asking questions and tearing stuff apart and realizing that all this stuff that we make, we made, and so we have the ability to take it apart. We can question how things work. And if you start questioning, suddenly you realize there are lots of ways to come up with answers for those questions. Engineering is one of those paths that allow you to find those answers. So if you want to go into engineering, the first thing is realize that you love to just take stuff apart at whatever level. If it's at the mechanical level, if it's the electronic level, if it's the software level, it's how do these things work? And once you realize you've got that in you, start finding ways to find the answers.
Let me ask you a question. Can everybody do math?
Everybody can do math, not everybody can enjoy math.
Okay.
But everyone can do math, and we do math all the time without realizing it. Probably the best algebra equation that people do continuously without knowing it is looking at their gas gauge and knowing if they'll have enough gas to get where they need to go. We do it continuously, but nobody ever thinks about the fact that's an algebra problem. And so once you realize that you're doing that, if you have a paycheck and you can tell me what your paycheck's going to be because of the amount of overtime you did without knowing that or seeing that paycheck yet, you're doing algebra. Those are all embedded in our daily life, but we get hung up on the idea when we start thinking about it as math.
That's outstanding. And I think a lot of times when we get to high school students, they either decide I am a mathematician or I'm not a mathematician.
Right.
But we don't think about the real application. And this class is really bringing that alive.
I hope so.
It's bringing application. It's also exposing them to new possibilities, new careers. Do you happen to have any idea, what's the median salary for an engineer? in today's
Oh,
market?
heavens. I haven't looked lately, but I'm going to tell you that we're probably about a $50,000 starting salary coming out of college, somewhere in that range. You probably got your low end coming in at the low 40s, high end probably coming in at the low 60s.
That's outstanding. And as far as the market, what are some companies that employ engineers?
Oh, around here, well, we've got NSK, employs engineers. The folks at Cummins employ a lot of engineers in this area. Eli Lilly employs engineers. But almost any manufacturing plant has at least one or two engineers on staff. And they don't necessarily have hundreds of engineers like a Cummins. But Allied Signal, which used to be here in Franklin,
Yes.
always had one or two engineers on staff. And so almost any factory or any plant you see has at least one or two engineers there.
It's a lot of opportunities for students, and that really brings our guiding principle, individual student growth, alive. This class does need some help as far as materials and maybe even other people to come in and share with their works
Right.
and jobs and vocations with the students. And if you'd like to learn more about the class or you'd like to talk to Mr. Rose, please contact the high school and they can get you to Mr. Rose. Also, if you'd like to contribute financially, this is a way to give kids an opportunity. This is a new class, so when we are looking at materials and supplies, it's also new for us. And so if you'd like to donate, that would be great. You can send that to the high school, also attention to Mr. Rose. Any closing thoughts or comments?
Just that anyone in this building has the abilities necessary to come into this class and really be a success.
Yeah. And I would agree. I've been able to go into the classroom a couple different times, and the engagement, we talk about that a lot in class. What's engagement look like? Engagement in Mr. Rose's class is very high. You are an active participant, and
yes.
I think the learning will be there for a long time because of that. So thank you for bringing this to our school,
Thank you.
but more importantly to the students. There's great value and opportunities. The future is abundant for them.
Well, thank you.
All right. With that, you've been watching Superintendent's Corner. Mr. Rose and I'm Dr. Clendening. Have a great day.